Alright, hello, welcome to the second part of your favorite artist electronist, Mr. Q12 experimentation with the blinking LED that I'm having there. So, I was actually doing something interesting. I made this circuit diagram here, and I pay attention on maximum voltage is 4.55 volts, and minimum voltage is 1.85, as you can see there. And, and this number minus this number, the difference is 2.7 volts. Then I made this circuit, this very simple circuit. I remake it. Actually, I remake everything a couple of times, switching the this wire, this yellow wire. I switch it back and forth from this point to that point, as you can see it right now. So right now is in this mode, is in this mode here, as you can see it there. The yellow wire is coming from between the two components there. And Vmax is 4.98, almost 5. Voltage minimum 2.3. As you can see, there is a slight difference from this voltage to this voltage. This is increasing and also increasing here. This voltage minimum maximum is, I took it from here, from this signal wire, and this voltage maximum minimum I took it from this point. You can see it here from this point here, and then from there. Taking this number minus this number, the difference is also 2.7. This is a coincidence, most probably, but I was hoping for an increase in voltage difference. So pretty much this here is too close to the voltage rail, is almost 5 volts, is quite 5 volts here. But this voltage minimum voltage is higher, while here is lower, under 2 volts. And probably because this voltage minimum is lower with the transistor, with the voltage drop over the base emitter, probably, or collector emitter, probably. I'm not completely sure, but it definitely got a lower voltage, this circuit. And being a little bit lower voltage, it worked to clock. But this circuit didn't work at all to clock anything. So this was a very interesting experiment that I did. And then I said, well, let me use an opamp, because I was very curious. This counter is not working here because it's connected to this other output, but I probed. I made a test in both sides, because this is a dual opamp. It's called LM358. And you can see here, this is the output here on the first pin, and the second pin here, immediately after the power supply, is the output for the second gate opamp that is having. So this is what I'm having there. And this is the positive rail here, and this is the negative rail for to power the chip. And I'm using the secondary op-amp, and this is the primary op-amp. And this is the frequency. Most important is this here, V max and V minimum. You can see with other I took a test with another op-amp and I got 20 millivolts. But with this op-amp that I'm having here is 100 or 80. But here the voltage maximum is 0.8. So the difference between this and this number minus this number equal 3. You see, almost 4. It was, yeah, it is 4. So 3.7. Let's say 3.7 here when it is 3.8. And I mean, comparative to 2.7, 3.7 difference is 1 volt up difference, and it's good. I wished to get to the 4.9 volts actually here, but for some reason this is taking 1 volt down. I'm not completely sure why it's eating so much. 1.2 volts like that is eating only this arrangement that I'm having here. So and this is one gate that I tested here, and next let's test the other gate. So what I'm doing right now, this is what I'm doing here. I'm connecting the signal wire directly from this point between the two elements, the two components between them. This point here, I'm connecting it to positive input. And the negative input, I leave it floating pretty much. And then I'm collecting the output on the oscilloscope. That's it. So let's switch to the other op-amp in the package. Actually, not there, here. And this here. And now the counter is moving, is working. And also I'm getting exactly the same square wave. Of course, it's fucking me because I'm touching something there. It should be a perfect square wave, as you can see all the time. And the voltage maximum and minimum, it got a little bit higher even. So probably, I'm not completely sure why is this V minimum jumping around. I got even plus 20 millivolts here. For some reason, I'm getting a very large. So it's 3.5 here, the difference. But the important thing is that it is a more decisive clock pulse, more higher in voltage than it was before with the transistor, which I had it before. So I made this experiment, and the voltage is clearly better right now. The voltage difference, the maximum and the minimum. And I made this circuit here. I used another LED, blinking LED, because I have 60 of them at $2.40, probably, if I remember right. So let's put this. Let me take this out, because not from there, because it will blink in the same time with this one, and it's not a good idea. So let me put this here, the positive. This is the negative. Where are you? Here it is. And it started to blink, but I need to add the probe. And it's exactly the same thing as here it was with this other one, but this time I put a SMD358, which I have a ton of them, and I made the exact same connections. I linked from this point to that hole a single wire underneath, and is getting out through that little hole and connecting there. This is the output here to this pad and to this green wire, and this is the positive link, and this is the negative link, and that's it. So it's exactly like as I had it here. And check this out. 4 volts here, but V minimum is 2.300 millivolts. So for some reason, this voltage minimum it got different. I got a voltage minimum of plus 20 millivolts. 20 it was there, not 200 as it is now. I'm not sure when and why it behaved like that. Probably it was an error or something, but usually it's around 100 and something. This in this case is 200 millivolts. And subtracting from this value, which is 3.8, 4 volts, 3.8, 3.6, probably is the difference from which is good, it's better. I wished I had a 5 volts. I wish I had more closer to 5 volts here for voltage maximum, and here to be, I don't care if it's 200 millivolts, 300 millivolts like it is right now, it's fine, it's good, it's okay. But if I was having more towards the 5 volts, it was better. I really hope. I'm not sure why it's getting so much voltage down, 1.2, almost 1.2 volts down. I'm not completely sure why, but if I will discover why is the reason, I will update this little project. But the idea for this circuit with the opamp is that it's quite the same dimension as with this other one. Let me take it out from here to actually compare it. As you can see, they occupy pretty much the same space, almost the same space. And also like this, if I'm putting them side by side, you see that it's the same size. And also like this, it's pretty much the same size. Probably this is a tiny little bit more wider than this, but pretty much is the same size, which I'm fine. And it's a bit more connections, you have to take care. But this arrangement with the op-amp is giving you, so this is the entire idea why I build it like this, is giving me a better range, a higher voltage difference. So it's 3.6, 3.8, or 3.7 to 0, pretty much. This is the difference from 0 to 3.8 volts, which is very, very good than 2.7. It's 1 volt up. So this is an improvement, what I'm having here. And I didn't make the circuit. I should probably make the circuit. I keep it off a little bit. And now this is what I'm getting. Voltage maximum is 3.9. Voltage minimum is 0 millivolts, which is excellent. This is what I was talking about. And actually 20 millivolts it was at some point. Come on. No, it doesn't want to go to 20, but I got to 20 millivolts. Minus 20 millivolts, actually, even. You see, plus 20. It was constant. It was staying at 20 millivolts for a while. For some reason, it's fluctuating. Probably it's fluctuating because of this little LED. That is not the same all the time. Probably is having some incorrections. Now I was making the circuit schematic, and I powered everything off. So before I was getting some errors. But probably right now is the correct. Probably right now is the correct values. I'm not completely sure. But anyway, now the difference is 4 volts instead of 3.7, which is better. Definitely is better than with the circuit with the transistor. That's the whole point of this circuit. So I made the circuit. Here is the comparison between the three of them. So I'm getting a difference of 2.7 for both of them. With the transistor, without the transistor here, but here with the opamp LM358, I'm getting two results. Probably this is a glitch with the 3.7 and 200 millivolts, some sort of glitch. And here, probably this is the most correct, and hopefully the normal result that you should get as well. For 4 volts for V max and 0 volts for V minimum on this point on the output. And here is the difference, 4 volts. And in this glitchy scenario, 3.7 volts and 200 millivolts, and the difference is 3.5-ish, 3.4 maybe. But the idea is that this voltage is way more higher than this voltage, with at least 1 volt or even higher, 1.3 volts higher. So this is better with an op-amp. And if you have a better op-amp than 358, which is true rail to rail, LM358 is not true rail to rail. It is eating a little bit of from the positive and from the negative, like this 200 millivolts probably. And here should have been 4.7, very close to the 5 volts. But for some strange reason, I'm getting 1 volt down. Yeah. Well, here is the reading again is continually showing me 0 volts or negative even for some reason. It shouldn't, but I'm getting it. Weird. Yeah, usually it should be 0 or plus 20 millivolts. In some scenarios, I got a continuous to positive 20 millivolts, and here is weirdly 4 volts. It should have been 4.7 or something like that, a little bit less than the power rail, but well, it's better. So that's it. I will not put this counter because it is making the counting. Yeah, I can put it here just to show you that it is actually working, but I will have to bend everything and put it here somehow. And it is not counting, motherfucker. Why the hell are you not counting? Because it's this other one? Yeah, because that other one didn't like it. So that's this is how I put the green wire on that link there, and it is counting now. But I have to take this out because it was interfering. It was probably putting a 0 volts here on the output, and it was surging the current from there. So that's it. It's working absolutely fine, and is a greater signal amplification. Logic signal is way more better with a small op-amp there. That's it. Thank you very much for watching, and see you later from my favorite electronics, Mr. Q12. Bye bye.